Good evening, everyone. Sorry, there was some echo earlier. Am I audible?
Yes, ma'am.
Okay. All right. So just wanted to know how was your quiz one? Was it easy, difficult, or how was it?
That was easy, ma'am.
Okay.
Ma'am, actually, I found a question. I have some confusion in that.
Okay.
So the question was
Hmm.
that regarding uh, like for ordinal data.
Yeah, there is in
Yeah,
that
yeah,
the
that
question
question.
that option should not be correct. Yes.
Yes,
Okay,
ma'am.
okay, ma'am. Then it is.
Okay. All right. So today we will now start with the contents of week 5. Okay.
Okay.
All right. So in this week 5, we are mainly going to concentrate on the topic permutations. Okay. So before even looking at what is permutation, we will first look at some basic principles of countings. What are factorials? Then we will slowly see the definition of permutations and then the varieties in which the permutations that can vary. Okay. So okay, so very basic principles. So here, just wanted to have something colorful here. So I added this example. So you have a coupon from a cafe that allows you to get one item, either a muffin or a milkshake. Okay. So now, what are your available choices? So you have 3 options for muffins and you have 2 options for milkshake. So out of this 5, you have an option to choose any one of them, right? So this is a very basic question, right? What is the answer for this, you think?
5.
Yeah, right? Because out of 5, you can choose any one. So the possible ways in which you can choose is 5 different ways. So any of the 5 you can choose, right? So either you can choose one muffin, so you have 3 ways, or one milkshake, 2 ways. So total number of ways here is simply 3 plus 2. So here you have 5 different ways to choose the coupon, right? So instead of this 3 plus 2, suppose you are having something else. Suppose let us say you are having um, three major courses and not 3, maybe let's say 5. 5 major courses and 2 electives. And you need to choose, let us say you need to choose any one course. So how many ways you can choose a course from this?
5 plus 2, that is
Yeah.
7.
Yeah.
7.
Yes. So you can choose this one course in 7 days, right? So,
Either at 5 or 8.
sorry, what?
Or is there? either 5 out of 5 which can be chosen or 2.
No,
So,
any one out of all these courses,
yes.
right? So the total options given to you is 7. Okay, fine.
Yes.
So here, this is this kind of question. So you are given some certain group, different groups are there, but out of all groups, you are asked to choose only one, right? So for this, there is a basic addition rule of counting. Okay, so if an action A can occur in n1 different ways, another action B can occur in n2 different ways, then the total number of occurrence of the actions A or B is n1 plus n2. Right? So here in each case, the number of ways you can choose one muffin, for example, in the previous case is 3 ways. And one milkshake is 2 ways. So here in this case, this is your N1, this is your N2. And in this case, this is your N1 and this is your N2. So your answer is N1 plus N2. Right? So the total number of ways is N1 plus N2. Okay, so this is addition rule for counting. Okay. Now, instead of just 2 categories, if you have more categories, then what happens? Suppose instead of just 5 major courses, 2 elective courses, there are some other additional courses, let us say 3 additional courses or 3, I don't know, let's just call it 3 additional courses. Suppose there are 3 other additional courses. Now, how many ways can you choose a course?
Ten.
10 ways.
10 ways.
So here again, you see that we are just, sorry. So we are just increasing the number of ways in which you
Ways.
can choose the same course, but now with extra number of options. So now here you see that now you have N1 plus N2 plus N3 now again, right? So now you have 5 plus 2 plus 3. So now 10, right? N1, N2, N3. Okay, fine. So now in exam next, so we'll see the next scenario. Now suppose the coupon that allows you to get 1 muffin and 1 milkshake. Okay, so the coupon is now allowing us to get 1 muffin and 1 milkshake. Okay, suppose that we have 3 muffins, 3 different types of muffins and 2 different types of milkshakes. So how many sets can we make? Right? So here you see that we have this blueberry and then strawberry and then some choco. So these are the 3 different muffins and then you have 2 milkshakes, some choco and strawberry milkshake is there, right? So how many combinations are possible? Because you are allowed to take 1 muffin and 1 milkshake. So how many combinations, how many sets can we make out of this? So you see that over here, this is 1 set. This is 4, 5, and 6. Right? So you are saying you have 6 sets. Right? So here what has happened? So here you see that N1 is 3 and N2 is 2. Right? And then the total possible sets is 3 into 2, 6. Right? So usually this kind of a problem is sometimes explained using a tree diagram. Okay. So for example, here you see, let's say that the first category here is muffins. So you have 3 different type of muffins. So let's say blueberry muffins, strawberry muffin, and then you have choco muffin. Okay. So you have first of all 3 possible options. And then from each option, then you have 2 more options, right? So next category is milkshake. So here, either you can choose strawberry milkshake or you can choose maybe here, maybe I should use a different way of writing. So strawberry milkshake or choco milkshake. Similarly, here also strawberry milkshake or choco milkshake. So here you see that the number of option is 1, 2, 3, 4, 5, and 6. Right? So this is multiplication rule of counting. Right? So what does it say? If an action A can occur in n1 different ways, another action B can occur in n2 different ways, then the total number of occurrence of the actions A and B together is n1 into n2. Okay? Sorry. All right. So can you understand the difference between the previous scenario and this scenario? So in the first case, we were allowed to take only one out of everything. Now you are given, you are allowed to take one from category A and one from category B. So this combination, how many possible sets is it is possible? N1 into N2, right? Now you have something more. Suppose the coupon that allows you to get one muffin, one milkshake, and one fried snacks is there. Okay. Suppose we have 3 muffins, 2 milkshakes, and 3 snacks. Now, how many sets can we make? So without even doing any calculation, can you quickly say?
18.
18.
So it is again the same logic, right? The logic is exactly same. So first you choose one of the muffins. So either you choose a blueberry muffin or a strawberry muffin or you choose a choco chip muffin, right? And then you choose one of the milkshakes. So either you choose a strawberry milkshake or a choco milkshake in each scenario. Right? And then you have 3 different snacks, right? So here you have 3 different snacks. So let's say snack 1, snacks 2, snack 3, right? So here also same. Right? So here in total, how many options are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Okay. So we have 18 different ways of choosing one item from each of these categories, right? So here, suppose this is your N1, this is your N2, and this is your N3. How many ways, how many sets you can make? N1 into N2 into N3. So 3 into 2 into 3, which is 18. Okay. Is this clear? Yeah.
Yes, sir.
So
Yes,
for
ma'am.
example, so what does this, for example, what does each of this tree means? So what does this particular choice means? What is the particular option you have chosen from this tree? If I choose this one, what does it mean? So you have chosen strawberry muffin and strawberry milkshake and the snacks too. So this is the combination you have chosen, right? So what is, so here each of this 1, 2, 3, 4, 18 is 18 different options. Okay, what does this tree means? That should be clear. Okay, so the tree diagram, the meaning of the tree diagram, is it clear?
Yes.
Yes, ma'am.
Yes, ma'am.
Okay. So here the summary is that suppose that all actions are to be performed in a definite order Further, suppose that there are n1 possibilities for the first action and that corresponding to each of these possibilities are n2 possibilities for the second and so on. Then there are n1 into n2 into nr possibilities altogether for the R actions. Okay, fine. Now let's see another example. So here, now this example, here they are going to create a 6-digit alphanumeric password. Okay, the requirement is as follows. The password should have first 2 letters followed by 4 numbers, right? So first 2 are letters. So totally you have like 6 digits. 1, 2, 3, 4, 5, and 6, right? So out of this 6, you have that first here A to Z. And here also A to Z because first 2 are letters. And then followed by numbers, right? So numbers, you have options 0 to 9, 0 to 9, 0 to 9, 0 to 9. Okay. So now suppose let us say the words or the letters or the numbers can repeat. In that case, how many options do you have for the first entry here?
26.
26.
26.
You have 26 options. Similarly, for the second entry,
26.
Also 26.
and for the fourth one,
10.
10.
here also
10.
10.
10. Here also 10. And
10
here
and 10.
also 10. Right? So when repetition is allowed, this is the possible number in each case. Okay? All right. Now you see here, if repetition is not allowed, it means what? Suppose the first letter is A, the second letter also cannot be A. Right? So this is the case when repetition is allowed. Now when repetition is not allowed, then you see that the first option does not have any problem. Right? The first option 26 is possible. But for second, one letter, number of letters to choose from reduces to
25.
25.
25.
and then numbers again starts from 10. And then for the second option, one number
Nine.
is reduced.
9.
9.
And then third, another number is reduced.
8.
8.
And
And
for
then
fourth,
7.
7.
yeah. Okay. So this is what happens when you have to choose without repeating any words or letters as given with the required conditions. Okay. So this example is also clear, right? Okay.
Then shouldn't it be 52 instead of 26? Because
Yeah.
small letters we can have.
Okay.
We have that foundation that only
Here,
the uppercase or lowercase is.
Yes,
so
ma'am.
here if they are mentioning that, okay, so this statement in this case, they should have been mentioned it more clearly. Now, for example, in this case, maybe let us say first 2 letters, which are maybe let's say caps letter, let us say. In that case, what we have done is correct. But if that is not the case, if both uppercase and lowercase are possible, then as you mentioned, then it should be 52. Okay?
Okay, ma'am.
Yeah. All right. So the next question here is order of finishing in a race. Okay. So there are athletes who take part in a 100-meter race. Okay. So let's say the athletes are like athlete 1, athlete 2, and athlete 3. Right? 3 athletes. We don't know their names. So let's just call them A1, A2, A3. Now, what are the possible ways the athletes can finish the race? Okay. So none of them can be in the same position at a time. Okay. So let us say this is the first position, second position, and third position. Right? What are the possible ways in which the athlete can finish the race? At the finishing point, what are the different possibilities? So either they can be in the same order or This is another error. What are the other possibilities?
9 possibility.
9, are you sure?
Yeah,
6.
9.
It should be 6, ma'am.
6.
Okay. So here A3, A1, A2, A3, A2, A1. Are there any other possibilities?
No.
So we have 6 ways, right? Yeah.
Yes.
Now instead of 3, now suppose there are 8 athletes who take part in the race. Now what are the possible ways the athletes can finish the race? So again, first place, any one of the 8 athletes. Second, any one of the remaining 7, and so on, right? So
8 factorial.
yeah, so here
8.
you see it is 8, 7, 6, 5, 4, 3, 2, 1, right? So the same is the case here also. So in the first position, we have 3 possibilities, and in the second position we have 2 possibilities, and then in the third, the remaining 1 person, right? So the total number of ways is 6, right? So 8 means 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1, right? So this is nothing but, you know that we call this as factorial. So this is actually 8 factorial, right? So what is factorial definition? The product of the first n positive integers is called n factorial, and it is denoted by this. Okay, n with an exclamation. So what is n factorial? N into n minus 1 into so on up to 1. Okay. So usually what does it mean by 0 factorial? So this is a convention. So many people tend to make the mistake. So by convention, 0 factorial means 1. Okay. So this is a convention. Convention means this is something like a rule we follow. Okay. Sorry. All right. So here you see what is mean by 5 factorial. 5 factorial is simply 5 into 4 into 3 into 2 into 1. Now what is 6 factorial? Can you quickly tell me what is 6 factorial?
720.
How much? 720, right? You just have to
Yes, ma'am.
multiply 6 with. Okay. Now observe 5 factorial is 5 into 4 factorial. So this formula is applicable for any n in general. N factorial is n into n minus 1 factorial. And this we can keep on applying repeatedly. So when you do the repeated application of the same concept, you have this general formula. N factorial is n into n minus 1 into so on. And you have n minus I plus 1, and then last n minus I. Okay. So this is just an extension of the formula you observe in 2. So what has happened here? So here you see that, so this is n minus 1, right? And then here this is n minus 2 factorial, right? So in this case, what is your I? If you compare it with this formula, your I is 2.
2, yes,
2.
ma'am.
Yes.
So what is n minus I plus 1?
So
Eight.
that is
N
3.
minus
It is simply
n
n,
minus 1.
right? So here it is n into n minus 1 into n minus 2 factorial. Okay. So in this specific case, your I is 2. Okay. Fine. This formula, all the 3 points here, is it clear for everyone?
Yes.
Yes,
Okay.
Yes,
ma'am.
ma'am.
Yeah. All right. So now let us specifically look at the term permutations. What is meant by permutation? A permutation is an ordered arrangement of all or some of the given n objects, right? So for example, if 3 students stand in a line, how many different ways can they stand? So the student names, let us say A, B, C. So now, let the students be A, B, C. Okay. So ABC, ACB, BAC, BCA, CAB, and CBA. Right? Now, how many possible ways we have seen? 6 ways.
6.
Right? So this is called a permutation. Right? In this permutation, what is important? Order is
Order.
important. Right? So where are they standing in the line is important. Okay, if order matters, then that is what we call, that kind of an arrangement is called a permutation. Okay. Now, out of 5 students, how many ways can we select 3 and arrange them? Right? So, first position, we can have 5 choices. Second position, 4. Third position, 3. So, totally, how many choices are there?
60.
5 fours are 20 and then 60.
60.
Right? So now out of 5, in the previous case, we were looking at only 3 students and how many ways in which all 3 can stand. Now here, instead of all of them, we are choosing only 3. Out of 5, how many ways we can select 3 and arrange them, right? Only 3 we are choosing. So in that case, so 5, 4, 3, right? So 60. So here, what is happening? So here, the number of possible permutations of R objects from a collection of n distinct objects is given by the formula n into n minus 1 into so on, n minus r plus 1. Okay, and it is denoted by npr is equal to n factorial by n minus r factorial. Why is this n factorial by n minus r factorial? Because here you see that it is 5 into 4 into 3. Right? So in 5 factorial, you have 5 into 4 into 3 into 2 into 1. This is missing here. Right? So how can I write this? Just divide by 2 into 1. So it is same as this. Right? So instead of this, I am writing it, when I am writing it as a formula, I am writing it like this so that it is easier to write it as a formula. Okay? So here, it is exactly the same, right? There is no difference in what we have written on the LHS or RHS. They both represent the same. Now on the RHS, what we have is 5 factorial by 2 factorial. Right? And what is n and r here? What is your n in this case?
5.
5,
And r is
3.
3.
3. So here you see it is n factorial by n minus r factorial. Okay. So the formula for the permutation, is this clear for everyone?
Yes.
Yes, ma'am.
ma'am.
Okay. Good. Now let's see some more examples. How many ways can 4 friends sit in 4 chairs?
4 factorial.
Okay, so here, what is
Yes,
your,
ma'am.
okay, yeah, what you are saying, the answer is correct. But just if you want to check it with the formula above, what is your n?
And
N
it's
is
4.
4. R is 0.
R is?
0.
Why?
Sorry,
No,
4.
R is
no, it
also
is
4.
4.
R is
Yes,
4.
ma'am.
R is
also
also 4.
So
Yes,
what
ma'am.
is
Yes,
your
ma'am.
NPR here?
So 4p4.
4
We
factorial
can write.
0, ma'am.
divided by
So 4 factorial,
0
4
factorial.
minus 4 factorial.
And what is
4p0,
4
ma'am.
minus 4 factorial?
4 factorial by 0 factorial. So 0 factorial is 1.
This 1.
So anyway,
So
you see,
24.
we can see that the formula also works here. Okay, what you said 4 factorial earlier is also fine. Just to check whether the formula is in alignment with the understanding, I just showed you this. Right? Okay. All right. Now, the next thing is, the next example is, how many ways can we form a 3-letter password A, B, C, D? Okay, where without any repetition. Okay, how many ways can we do this?
4p3.
Yes. So you have 4 P3, right?
Yes.
Because you see that. So 3-letter password means you just have 3 possible So only three boxes you have. In the first box, you have 4 options and no repetition. So the second option,
Three
you
and-
have only 3 and then 2. So 4 into 3 into 2.
20.
Yeah, which can be represented as 4p3 and it is same as 4 into 3 into 2, which is 24. Is this fine?
Yes, ma'am.
Yes, ma'am.
Yes.
Yeah. So this is a very regular question in permutations and combinations, right? How many ways can we choose 2? So out of the 2 students, one is captain and another is a vice captain from 5 students, right?
5p3.
5p
5p2.
2.
Yeah, so remember here, not any 2, we are very specific about these 2, right? So here it means that here order matters. So here we are looking at permutation. So it is 5p2,
5p 2. Yes.
right? What is 5p2? Can you quickly calculate?
Ma'am. 20.
20. Right? Okay, good. So far everything clear, right?
Yes, ma'am.
All right.
Yes, ma'am.
Okay, so this is the main thing we need to remember. Permutation means arrangement is there and that arrangement order matters. Okay, fine. Now, just to understand a few things more clearly, from 5 students, how many ways can you select and arrange 0 students? It is kind of like absurd question I'm asking, but just to make sure the formulas what we are studying, whether we understand it clearly or not. So I don't want to choose actually any students, right? How many ways you can select and arrange 0 student? What does it mean? Choose 0. So
Only one way.
R is 0, N
Ma'am,
is
1, ma'am.
So I'm
5.
not choosing anyone from here.
Hmm.
Right? So
Yes,
there is
ma'am.
nothing to arrange. So how many
Uh,
ways you can do nothing? Only one way you
Only
can.
one way.
Yeah.
Yes, ma'am.
Yeah, so here NP0 is
1 only. Yes. N factorial by n factorial.
and according to the formula, what does it mean? N factorial.
Divided by N
Divided by
factorial.
n
No, no, no.
factorial. So
Which
1.
is 1. Okay, fine. From 5 students, the next question now I am asking. From 5 students, how many ways can you select and arrange one student? You
5
can
ways.
any one of the 5 students,
5
Yes,
ways.
5
5
ways.
Yeah, 5 ways.
right? So 5 ways. Answer is 5 ways. So how does it match with your formula? What is your N
5.
5,
5.
5.
and your R is
1.
5.
1. So your NPR is N factorial by N minus R factorial. So here basically it is N
5.
minus 1 factorial, which is N.
Yeah.
Okay. So number of ways of choosing one item from n items is n. Okay. Now the next question, from 5 students, how many ways can you arrange 5 students?
5 factorial ways.
Yes, ma'am.
5
5p 5.
120.
Yes, ma'am.
5 factorial.
5 factorial
5
ways.
factorial.
5 NPN is n factorial.
5p 5. So 5
So n is 5, your r is also 5.
5. Yes.
So NPR, when n and r are same, what happens? This is something which I already showed you,
Yes,
right?
ma'am.
So n factorial by 0 factorial. So here in this case, it is simply n
N
factorial.
factorial. So
Right?
120.
7.
Yeah. So here, number of ways of choosing or arranging n item from n items is n factorial. Is that clear? Yeah.
Yes, ma'am.
All right. So here, this is what we have seen so far. NP0 means it is 1.
One.
Because it is n factorial by n minus 0 factorial. So there is only one ordered arrangement of 0 objects. And what is meant by NP1? It is there n ways of choosing one object from n objects. Right? So here, what is NPN next? We can arrange n distinct object in n factorial ways. Right? So this was what we earlier saw as multiplication principle of counting. Right? Okay. So far, is everything clear?
Yes, ma'am.
Yes.
All right. So moving to the next question here. Find the number of 4-digit numbers that can be formed using the digits 1, 2, 3, 4, 5 if no digit is repeated.
IP4.
So here you are now having always remember, if you want to do some permutation, you can make boxes like this for better understanding. So you have now 4-digit number, right? So no digit is repeated. So what? How many options are there for the first box?
5
Five.
options.
5.
Second,
Then
Four.
4.
no digit is repeated.
Yes, ma'am. Then 4.
4,
Then 3.
2.
Then 2.
And 2.
right? So it is
Yes.
5, T, 4. What is the answer?
120.
120.
120.
Sorry.
No, ma'am. 120.
So it is 120.
Yes,
5 4s are 20, 3 2s are 6. So 6 into 20, 120. Now they are now making the question a little complicated. Now if I want to see how many of them are even. So for an even number, what is the condition we need?
The unit digits should
2 and
be
4
divisible
should be
by
4.
2.
So the
Yes.
last digit must be
So
2 or
divisible by
4.
2.
must be even. In our case, what are the possible options? So
2
it
and
can
4.
be
2
Ma'am,
and 4.
5P2, ma'am.
either
2 or 4.
Either 2 or 4.
or 4.
Means addition will be
Hmm.
happen.
Yeah. So in that case, suppose let us say now in this, out of this, all these options, now we have 2 different scenarios. So in the first scenario, you see this number here is fixed. This is a number. It is a fixed number, right? Similarly, in the second scenario, the last digit is again fixed
4.
at 4. This
Ma'am,
is fixed.
20 possibility.
Yeah. So here you see the first case, how many possibilities? 5 into 4 into 3.
Ma'am, that should be 4 into, I mean, because 2 is out, right? Repetition is not
Yeah, yeah,
allowed.
yeah.
Yes, ma'am.
So now here we have, so only choices are, now we should remove 2. So 1, 3, 4, 5. So now out of this, so here how many choices we are having?
4 choices.
4,
3,
3, 2. So 4 into 3 into 2.
24.
24.
24.
Similarly, here what are the only choices?
Same. 4
Same,
into
ma'am.
3 into 2.
24.
1, 2, and 3 and 5. So again here 4, 3,
4,
2,
3, 2.
so 24.
20.
Right?
Yes.
So total
48.
48.
48. Right? Clear?
Yes,
Yes,
ma'am.
Okay. So the next question, you have 6 people to go, they are going to the cinema. They sit in a row with 10 seats. Okay. Now there are two different questions. Find how many ways can this be done if they can sit anywhere. So this is a very straightforward question. You have 10 seats and you are going to make six people sit in 10. So the answer should be straight away
10p6.
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 10p6, right?
Yes,
Now instead of this, now if the question is all the empty seats are next to each other, then what should we do? So now out of the 10, you have some
Yeah.
empty seats and all of them are together. So
Yes.
what should be done?
Ma'am, we can
Then
we can club those empty seats into one object. Then we have 6 plus 1.
Yeah.
That is 7. So 10p7. Or I'm not sure about it. Just
What you are saying is more or less correct only. So you are now, what you are saying, so now you are having some empty seats and they are together. So together means how can you consider them
As one.
as one, right? So if they are considered as one, then how
it's a
many
unit
possible
weight.
seats? Yes, how many possible seats are there first of all?
Total 7.
Yeah.
If second case we consider.
Sorry, what?
I said, ma'am, just
So now we can
total seats will be 7 if we consider second case, because the 4 seats will consider as one, and the
Hmm.
remaining 6 and 1 will become 7.
Yeah. Right? So you see that all empty seat is now one seat and 6 seats are occupied. So totally how many seats are there? Available
7.
seats. So maybe instead of available, let's say total seat is 7. Now out of this 7, how many possible ways we can arrange the 6?
7p6.
7p6. Okay. So answer is 7p6. Is that clear? Why 7p6?
Yes, ma'am.
Okay. So next question here is form 3-digit numbers using digits 1, 2, 3 with repetition allowed. So this is something we have done several times. Maybe instead of 1, 2, 3, we had ABC earlier, right? So what are the different possibilities? Now remember the scenario is different. Now repetition
repetition is
allowed.
allowed.
So how many possible ways we can do each position? How many choices is it having?
3 choices.
Each
So
is
3 cube.
3 into
should be
3
the
into
answer.
3.
3 to the power 3.
Yeah. So totally we are having like let's say here again
27.
3 choices, 3 choices, 3 choices. So you have 3 into 3 into 3,
27.
Yes, ma'am. 27.
right? So now the same question just slightly modified. Form 3-digit numbers using digits 1, 2 with repetition allowed. You have again the same 3-digit number, but now you have only 2 choices.
2 to the power
2 to
3.
the power 3.
So
Yes.
here
8.
each position, only 2 choices. So 2, 2, 2. So you have 2 into 2 into 2, 8. So 8 possible, right? So what is the observation here we have? The number of possible permutations of or objects from a collection of n distinct objects when repetition is allowed is given by n bar r. Okay. So here, for example, what is your n in this case? Your n is the number of boxes, right? And then R is number of choices. right? Here number of boxes and number of choices both are 3.
Three.
And here, what is the number of boxes?
2.
Number of boxes,
Boxes is 3.
right? And number of choices,
2.
2.
2. So here you have n power r. Oh, did I make
Nahin,
any
nahin.
mistake here?
Yes.
Yes, ma'am. So
N
n should
should
be
be 2
So it's still
and R should be 3.
So here then I have to change this as
You
well.
have to
It
switch
would
it.
be 3 square.
Sorry. So number of choices and number of boxes here. Okay, so the number of possible permutation of R objects from a collection of n distinct objects. Okay, when repetition is allowed is given by the formula n power r. Okay. Okay, so now the question is going to be slightly difficult. Suppose we want to rearrange the letters in the word data. Okay, what is special about this word data?
Ma'am,
A
2
has
A's are
occurred
there.
2 times.
2
Similar
A is
object.
there 2 times.
Yeah, so here some repetition is already there, right? So how many distinct letters are we having? So
Ma'am, 3.
3.
distinct letters, you have 3. T,
Yes, ma'am.
A,
A
and
and T.
right?
Yes.
So now here we have 4 possible boxes, but only 3 distinct letters. So what are the what can be the possible answer? How many ways can it be done?
Ma'am, n to the power 3. So 4 to the power 3.
You have to think carefully. Think again.
We can arrange in
Ma'am, we
the
have,
form of n factorial by p factorial.
can it be 4 factorial divided by 2?
2 factorial. Yes.
2 factorial.
Why
Yes,
it is
ma'am.
4 factorial by 2?
Ma'am, because the number of letters in that data is 4. So 4 factorial and 2
Ma'am, we can,
factorial represents that
yes, we can
same
treat
kind
this.
repetition is 2 times.
Yes. So here again, if we are making boxes, let us say 1, 2, 3, 4, right? So we have 4 boxes now, right? So now in each of these boxes, so the first option, so here let us say we are rearranging, right? So suppose if we are like counting this as A1 and A2, it's 2 different letters, suppose we are counting, right? Then what happens? The first position, how many choices is it having?
4 choices.
4. Second one,
3.
3.
2, and then 1, right? But then remember, these 2A are same,
Hmm.
right? If these 2A are same, then what does it mean? If these
Repetition.
we have
Means
Repetition
these,
is there.
yes. So
The
these
A,
2 can be arranged by itself in 2 factorial ways.
yes.
Hmm.
So A1 can be arranged in 2 factorial ways, right? So then we have to remove this 2 factorial ways from this. So it means what? We have already 4 factorial ways, but then this has to be eliminated from this total 4 factorial. So we have to divide it by this
2
2.
factorial.
Okay? Is this
Ma'am,
make sense?
yes, ma'am. Ma'am, if we are removing something, then like we can just subtract that, right? I mean, like why we are dividing this here?
Why are we dividing this? Because
Yes, ma'am.
here it is kind of repeating twice. So for example, let us say T A1, A2, T. Okay.
Okay.
and B A2 A1T. Are they different or same?
They're different.
They are not different. They are just for understanding this boxes, we have made A and A
If we are considering A, then it is same.
same. They are actually the same, right? So they are kind of repeating. So whenever some things are repeating and we have to eliminate them, then we have to say it is repeating how many times. Okay, you see what is happening, why we are dividing and not subtracting them, right? It is kind of repeating that many times. And hence we
Okay.
are removing, dividing by 2 factorial to remove the repetitions. You
Okay.
understand?
Okay, ma'am. Okay.
So every time you have this kind of an arrangement, the same thing is possible again. So you can imagine that as this. So it is kind of repeating every time. So you are dividing by 2 factorial and not subtracting that. You understand? Yeah.
Yes, ma'am.
All
So
right.
suppose there is another pair which is A1D T A2. Then like if you were subtracting, then we have to also subtract that. So in that sense, can we say that if we are dividing by 2 factorial, then like for every combinations that has been made, just like this A1, A2, those will be eliminated.
Yes.
Is
Yes.
that okay? Okay.
Okay. Good. Now,
Okay.
a slightly modified version of this question. So here the understanding is the number of permutation of n objects when p of them are of one kind and the rest is distinct is equal to n factorial by p
P
factorial,
factor.
right? Okay. Now we just had one repeating item, but instead of one, suppose we have more repeating item. Then what? I thought I had that example, but anyway, it's not here. So, for example, suppose some other word, let us say.
In the lecture, ma'am, statistics word is used.
Statistics itself.
Statistics. Okay, so let us maybe start with statistics. So, consider the word statistics. So here, what are the distinct word letters in statistics, first of all? S, T, A, I. Right? These are the distinct letters.
C also.
C also.
C. All right. So in S, how many S repeats how many times?
3 times.
S
Yes,
repeats
ma'am, 3.
times. And T repeats,
Same. 3 times.
A repeats,
Once.
and I,
2 times.
2 times. T,
Once.
okay. So in this case, how should the formula go?
10 factorial divided by 3
The
factorial
total number
into
of,
Yes,
yeah,
ma'am.
total number of letters here is 1, 2, 3, 4, 5, 6,
10.
7, 8, 9, 10. Right?
So 10 factorial.
Yeah, so here you have 10 factorial and then every time you repeat, you have to remove those part, right? So you have to remove 3 factorial. Again
3
here,
factorial.
sorry. So where we? By mistake, I pressed something. Yeah. 3 factorial, 3 factorial. And 2 factorial. Right? So this is the number of possible combinations, number of possible ways you can arrange this 10 letters. Is this making sense?
yes, ma'am.
Yes, ma'am.
Yes.
Okay, good. Okay, so now the next scenario is how many ways can 4 people sit in a round table? Okay, so first of all, consider the 4 people as A, B, C, D. So let them be the 4 people. So for example, you consider these, there are several ways you can arrange them. So only this particular instance, for example, if you consider A, B, C, D, B, C, D, A, C, D, A, B, D, A, B, C, right? So if they are sitting in a row, you can see that these are like different arrangements. Now let us look at the same combinations, like same type of arrangements in a circle. So first one is A, B, C, D. Second one is B, C, D, A. Third is C, D, A, B. Fourth is D, A, B, C. But now look at the circle every time. So this is just like rotated towards this side. So this table is just this. Just the positions are the same. A and B are neighboring. B and C are neighboring. C and D are neighboring. Right? So you see that the arrangement is not different when you see them arranged in a circle. Only when you see them as a arrangement in a line or a row, you see them different. But if they are seated in a circle, the arrangement is exactly the same. They are not different. Do you see the difference between the first and this in a arrangement in a circle?
No,
Yes?
ma'am.
You don't understand it? You
Ma'am,
understand?
I said that no, we cannot see any difference.
Yeah, so here the thing is that the arrangement is same, but here when you are seeing in a circle, here all the arrangement, all A, B, C, D, if you are putting them in this way, everything is same. Right? Okay, so how to understand this? So now to fix this problem, what we can do? So let's fix one person. Let us say we are fixing the person A, right? So in the circle, now I am fixing this person A. Okay, this remaining BCD, I have now how many ways I can move them around?
3 factorial.
Yes. Okay, so I can arrange them in 3 factorial ways, right? So you see that if A is fixed, then you have 3 factorial ways. In this way, have we covered all possible ways of arrangement?
I guess yes.
Yes, right? Because you see, here, these are the only possible ways, right? I have fixed A in each case. And then just the BCD I have changed. In this way, I have made all possible combinations in the round table. And I have avoided the confusion of having this same type, but then just the table is like in a different position. That confusion is avoided because I have fixed one person and the remaining are changing. Right? So do you see what we have done here? So to remove this problem, right? Remove this problem, I have fixed one person and then I have checked the arrangement of the remaining people. So what I have done by fixing one person, so out of the n, I have removed one
One.
and then I have,
Minus 1 factor.
okay? So here, the number of ways n distinct object can be arranged in a circle, either clockwise and anti-clockwise, is equal to n minus 1. Note that here clockwise and anti-clockwise are different because here you see, if you are looking at this clockwise, then the position is actually A, B, C, D. But if you are looking at the anti-clockwise, then it is actually A, D, B, C. Right? They both are different. They are not same.
Ma'am,
So
ADCB, ma'am.
Oh, sorry. Okay, they are not same. Okay, so in that case, when when the clockwise and anti-clockwise are different, then in that case it is n minus 1 factorial. Okay, all right. Now if the clockwise and anti-clockwise are same, then what happens? So in the previous case, the clockwise and anti-clockwise are different. If they are same, then what happens?
Then half of them will be
Exactly.
eliminated.
Exactly. Half of them will be eliminated.
Yes,
So how
ma'am.
does the formula get modified?
divided
n,
by 2.
n minus 1 factorial by 2.
Exactly. So you will have simply n minus 1 factorial divided by 2. Okay, so this permutation and combination is completely intuition. Okay, fine. So
Yes,
up to this, is everything clear so far? Are there any questions in whatever we have seen so far?
ma'am, I just have a question regarding this circular thing.
Yes.
So ma'am, if we have, let's say, 5%
Hmm.
and we want to arrange 3%
Hmm.
in a circular table,
Hmm.
so then can we say that let's say persons are P1, P2 up to P5, then
Hmm.
can we say that if we fix P1, then we can have 4 P3 ways, right?
So now you want to arrange 5 people.
Like 4 people out of 5 people in a circular arrangement.
Okay, 4 people out of 5 in a circular arrangement. Okay.
Yes, ma'am.
So you want to know how that formula will work, right?
Yes, ma'am. I
Okay.
mean, I am thinking a way to do this. I just want to get confirmed, like if I am right or wrong.
Okay, so the thing is that here this is actually moving to the next topic, which is combinations. But if you want some intuition, the intuition comes from what we have seen so far, right? Basically, you are going to arrange 4 people only in a circle. So if you want to arrange 4 people in a circle, do you know the answer?
Yes, ma'am. That will be like 3 factorial.
Yes, so that you know. Now, how many ways you can choose these 4 people? Like every time, this 4, like
Acha, 4 means 5p4 ways if we have 5 people.
yeah, so you basically are doing 5 times whatever you are doing. So this 4 minus 1 factorial, you will have the same thing repeating 5 different times. So 5 times of this will happen. So this is basically what is called combinations. So this anyway we will be doing in.
Oh, okay. Okay, ma'am. Okay.
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 Okay, fine. So what's next here? I guess next part is basically just this calculation thing, I guess. What was it? I don't remember. Just give me a minute. I'll see if I have that calculations. It is just understanding this calculation part. Because that should not be any problem. So let me choose what, see what they have done. Okay, so there is a question. Let me write the question. Find the value of n if np4 is equal to 20 times of np2. So how do you think you can solve this? So straight away we can apply the formula, right? So here, if you straight away apply the formula, what is the formula for np4?
N factorial divided by
n
n minus
factorial
4
by n minus 4
factorial.
factorial.
And np2 is?
N
n
factorial divided
factorial by
by
n minus 2 factorial.
factorial.
Okay. Now, n minus 4 factorial and n minus 2 factorial. Which one is bigger? N minus 4 or n minus 2?
N minus 2 is bigger if
N
n is
minus,
positive.
yeah. So n minus 2 is bigger because, sorry, because n minus 2 is bigger because, so for example, if you take any specific number for n, then what happens? Suppose n is equal to 7, then what happens?
N minus 2 is 5 and n minus 4 is 3.
Yeah. So in this way, you know what you should be cancelling out, right? So for first of all, n factorial and n factorial, you can easily cancel them out. So this gets cancelled. Then what is remaining? So you have n minus 2 factorial is equal to 20 times of n minus 4 factorial. Now, how can you write n minus 2 factorial in terms of n minus 4 factorial?
We
minus,
can write
2
n minus
into n
2
minus 3.
n
N
minus
minus
2
Into n
factorial into n minus 3
into
into
n minus 4 factorial.
n minus 2 only will be there. Factorial will be there.
You understand what's going on here? See, suppose you are
Mm.
having here, let
Yes,
us say
ma'am.
5
That
factorial,
descending order.
and in this side you are having 3
Okay.
factorial. How will you compare them? So you write it as 3 factorial into 4 into 5. Right? So here we'll find the 3 factorial. So this will get cancelled out. The same is what we are doing here as well. Right? So here,
Shouldn't be, ma'am, n minus 4 into n minus 3 into n minus 2 factorial.
that is what I'm saying. Maybe I'll make this better. I'll write it maybe in a more understandable way. So let us specifically first understand it for n is equal to 7. Okay. So now 7 factorial is n factorial. Now let us say what is n minus 2 factorial?
5 factorial.
5 factorial.
5 factorial. Now what is n minus 4 factorial?
3
3
factorial.
3
factorial.
factorial.
3 factorial. Now what is the relation between n minus 2 factorial and n minus 4 factorial? This is your n minus 2 factorial. Right? And this is your n minus 4 factorial. How did you write n minus 2 factorial in terms of n minus 4 factorial? So n minus 2 factorial, you can write it as
N minus 4
N minus
into n minus 3
n
into
minus 2
n minus 2
n minus
factorial.
2
n
into n
minus
minus 3 into n minus 4 factorial.
so n minus 4 into n minus, this is 3 into n minus 2. So that is exactly what I wrote here
Yes,
also. So here it is n minus 4 factorial into n minus 3 into n minus 2 is equal to 20 times of n minus 4 factorial. Now you can cancel this out. So what you have n minus 3 into n minus 2. If you multiply, what will you get?
N square minus 5 plus 6.
n square. Yes.
So if you simplify this, you will get n square minus 5n minus.
14.
14. So
So how will you
Nine.
So
solve this?
7 and 2.
minus 7n
Minus
plus
7 and
2n
plus 2.
minus 14.
Yes.
So the possible options are n is equal to 7 or 2.
So,
Minus.
Ma'am, n
Nine.
can't be minus 2, so that's why
Hmm.
n is 7.
So this is not possible. So n is equal to 7.
7. Yes.
We are only looking at natural numbers. So this is the only option here. Is this clear?
Yes, ma'am.
I lost the connection, ma'am. Actually, what was the question, ma'am?
So the question is find the value of n given this condition np4 is equal to 20 np2.
Okay, got it.
All right. So let's do a similar question. Find n if you are given np4 by n minus 1 p4 is equal to 5 by 3. Now how should we do this? Again, apply straight away the formula. If you straight away apply the formula, what will you get?
N factorial n minus 4 factorial.
And then here you
So
have
divided by n minus 1
factorial.
factorial.
N minus 1 factorial. Or by n
N
minus 1
minus
minus 4 factorial.
n minus 5.
Right now this I can just for a easier purpose, so I can rewrite it as n factorial by n minus 4 factorial is equal to 5 by 3. N minus 1 minus 4 is minus 5
N minus
factorial.
5 factorial. Yes.
Then n factorial. And then again, just like we
Yes,
did in
ma'am.
the previous problem, this is n minus 1 factorial into n, right? This is n minus 4 factorial, which is 5 by 3. And this is n minus 4 factorial into n minus 5. correct?
Yes, ma'am.
So divided by n minus 1 factorial. So what do we have? Did I make any mistake? It looks like I have made some mistake.
I have that n minus 5 factor.
Ma'am, actually,
One.
this
So,
in the
n
right
into n
side, it
minus
should
1.
be 5 by 3 into n minus 1 factorial divided by n minus 5 factorial in the second step.
Oh, okay. Yeah,
And because that
correct.
gone to another side.
Yeah. So this is n minus 1 factorial divided by n minus
5
5
factorial.
factorial. All right. Now, how can we simplify this? This is in the numerator. It is n minus 1 factorial only. Now, how can we rewrite this n minus 5 factorial here?
N minus 5 into n minus.
No,
No,
ma'am,
no,
we
no.
can write
Ma'am, we
n
can
minus 4 factorial as
Yes,
n minus 4 into n minus 5.
5 factorial in that
Yes.
way.
Right? Now we can
Yes.
simplify this by striking this out. So what is remaining? So you have n by n minus 4 is equal to 5 by 3. So this means 3n is equal to 5n minus
N minus 20.
20. So you have 2n is equal to 20. So n is equal to
10.
10. Is this clear? Yeah?
Yes, ma'am.
All
Yes, ma'am.
right. Okay. So you have one more problem. Now instead of finding n, so now you have to find r if 5pr is equal to 2 times of 6pr minus 1. So now again applying the formula, what will you get?
5 factorial
minus
5
divided
factorial
by
divided by 5.
5 minus
5
r
5
minus r
minus r
factorial.
It's 2 times of
6
6
factorial.
factorial,
6 factorial. 6
Divided
6
by
minus r
minus
minus 1
factorial.
right? So 6 minus r minus 1, so it becomes plus 1, right? So
Yes.
here you have 5 factorial by 5 minus r factorial, which is 2 times of 5 factorial into 6. And then here 7
7
minus
minus
r factorial, right? Now, how can we rewrite this? So first of all, we can strike out this term. So 5 factorial and 5 factorial, we can strike out. And then how can we rewrite this part? So let us
Ma'am,
say
7 minus
7 minus r
r
factorial.
7
factorial.
minus r into 6
7
minus
minus
r
r
minus r
into
into
6
5
minus r
minus
5
into
minus
5
r
minus
factorial.
r factorial.
So why we are able to write like this? Is this clear for everyone, this step?
Yes, ma'am.
Yeah, this is clear for everyone, right?
Yes,
If
ma'am.
anyone have doubts, please let me know. Okay, so now if we have this, then we can cancel this one out. So once we can cancel this, so what is remaining to us? So here 6 minus r into 7 minus r is equal to 12. So this means you have r square minus 13r and then plus 42 minus 12 equal to 0. So r square minus 13r plus 30 equal to 0. So what will you have?
R square minus 10r minus 3r. So we'll have
R minus 10 into r minus 3. So basically you have two options. R is equal to t or 10. Right? So whenever you have such a solution, always check whether the question makes sense for whatever answers you are getting. Okay? So
yes.
if r is equal to 10, will it make sense? 5
No,
p.
ma'am.
No, ma'am.
It
Yeah.
is not
Because
possible.
n should be greater than
Yeah. So r is equal to 10 does not make sense
r
because
will be
for
3.
n is equal to 5 and it is less than 10. So this is not possible. So the correct option is R is equal to 3. The answer. Okay. Good. Just wanted to tell one thing. How many of you are familiar with LaTeX?
What, ma'am?
LaTeX. Do you know what is mean by LaTeX? Anyone? Okay, if not, you don't have to learn anything because these days any programming language, there is nothing much to learn. At least you just have to understand some basics, and then you have all these AI tools to help you to write the code, right? So similarly, LaTeX is a code where you can type math or stat. So to type, so this is basically for typing math text, right? So this is useful in many places. So just wanted to tell you that whenever you are free, explore what is LaTeX. Okay, just like
Okay.
for Python, you have this online tool called Collab. So for LaTeX also, there are offline tools and online tools available. So in online, you have something called Overleaf. Okay, so you can explore it with Overleaf files. So Overleaf files you can share, create and share, comment. So many things are possible. So you can try this LaTeX because if you, for example, if you are applying for the first stage where this can be useful is when you are applying for a TA position. So this is definitely going to be required. Okay, so LaTeX you should know if you are applying for TA position, right? Also, this is going to be useful for your higher education. Also, suppose you are submitting a project where you are using some calculation, you are showing some calculations and all. It will not be good if you are typing everything in some Word doc. So in that case, if you have some mathematical calculations to be shown in your project or in your research publication, then definitely you need, and for any research publication, usually LaTeX is what is used so far. Okay, maybe there are
Okay.
few other tools. So LaTeX is always useful. So just a suggestion, everyone should know what is LaTeX. Whenever you have time, slowly just search about it and get to know how to use LaTeX.
Yeah,
Okay.
that's good.
Okay.
All right. So this LaTeX has nothing to do with this particular session. Just I thought that maybe I'll tell you guys about this. All right, so you see that permutation is more about intuition, understanding about how you can do certain things. So you just have to think, imagine, and then do it. So the formulas, sometimes you may get confused. It is very much possible that you get confused. So to one suggestion, whatever problem you are having, if you are given big number, suppose let us say 7 and 3. So instead of 7 and 3, take some small numbers and see. Instead of 7, if you take, let us say 3, and instead of 3, you have 1 or 2. So what is the answer? So try something like that and try to understand with small numbers and see what is happening. So this is one way to imagine the problem given to us. Okay, if the numbers are big, try to reduce the numbers and see what is exactly going on to have a visual understanding of the problem you are trying to solve. Okay. So this will help you if you are getting confused with the specific questions. Okay. All right. So in the next session, we will be discussing all your assignment questions, whatever doubts you have in any of the assignments, we can discuss all the questions. So it is on Friday, I guess. Okay. So we will meet again on Friday and discuss again the same topic, but specifically we can address your doubts on that day. All right.
Okay.
Okay.
Thank you so much for the session.
Okay.
Thank you, ma'am.
One. Yeah.
Thank you, ma'am.